Boot, boot. Okay, so yeah, audio is here.
Yeah,
Yeah, perfect.
testing audio as well.
So the delay, we shouldn't care. It doesn't matter.
Yeah.
Yeah, it's off on the other side. You can turn it on. Long press on this guy. And
Okay.
go ahead.
Testing 1, 2, 3.
Yeah,
This
perfect.
thing is working.
Perfectly, actually.
Nice. Okay.
That's it. Like you can see the noise cancellation on these things is pretty brutal. It's pretty good. 'Cause I can
Nice.
talk to you here, and that's pretty good. You don't hear the music that much.
I do hear the music, but
No, but like
the question is, do I hear the music through the headphones or is it
I,
the mic picking it
I
up?
think there's a little bit of it in the mics, but not much.
Well, we can turn the music up.
Yeah,
At least inside.
they will turn it off. It's fine. Yeah. Okay.
Should I ask to test?
Okay.
Or it's...
No, I think it's good.
Okay.
Yeah, actually, I don't hear it. No.
No?
No.
Okay.
I can hear you. Okay.
Good.
Yeah. If anyone is tuning in, we're not live streaming yet.
To viewers, yeah, tune in and get back to us in 20 minutes for real content.
Yeah, we'll be back, guys. Well, yeah, I was helping them. Let me actually.
I really love Azure Sphere, and I've done some software recently.
Yeah.
Go ahead and go live with that.
Yeah, we're gonna go live. So we'll finish the conversation after. Let me actually, it's this one. I'm gonna go. And I'll press it a second time for noise canceling. That's on. Okay, oh good. Okay. We'll give it 8 seconds. And then we'll get started. So once again, pretty informal. Like, okay, the people I think can hear us already. Perfect. Awesome. Hey everyone.
Howdy.
Thanks for joining us. This is the IoT Show. We're live, and now no one is online, but people will come up, I'm fairly sure. That's the first time we're doing live for the IoT Show. I hope you'll enjoy that. If that works, we'll do that again. And we're starting tonight. We are at Embedded World. That's in Austin. That's the first time the event is happening in the US. And we'll see pretty interesting people coming up tonight. We'll see people coming up with their beers, with their drinks, and we'll have a conversation. I have not prepared any specific topic, but I'm sure people like Jason here will have plenty to say. Jason, thanks for coming today. How are you?
I was supposed to talk about something?
Maybe. We have 10, 20 minutes, you know?
Okay.
And we'll try to entertain people there.
We can talk about Texas. This is my home state.
It is, right?
Yeah,
Are you living close
No,
by?
I live in Michigan now, but I love Texas still.
You're originally from here?
Texas barbecue,
I
good Tex-Mex.
I have to say, barbecue good. We went to a place with my wife last year. It was that like remote restaurant, barbecue restaurant in the middle of nowhere, eating on the wooden table with a paper
The
plate,
paper,
whatever.
the pickle, the cheese, the onion, like
That was
the
awesome.
bread, like that's the way
That
to
was
eat
awesome.
Texas
So we
barbecue.
arrived and we said, "Yeah, we're gonna go with the all you can eat." And the guys looked at us like,
Yeah, no.
"Yeah, we want to try everything." Didn't go so well. But anyways, so tell me a bit about yourself. So for those who don't know you, tell me about who you are and why do you have such a nice T-shirt?
Yeah, my
on you?
nice little puppy dog eating raspberry pie. So I spent almost 30 years at Texas Instruments, and I decided that I'm a product of what happens when you let software people have too much control over hardware,
Yeah.
right? And so I tried to get people to help me make hardware that was more suitable for my software tastes.
Okay.
Especially running new architectures like ARM initially, and now RISC-V, to run embedded systems, right? So making things into appliances, but always open source,
Okay.
right? So hardware that's open source hardware to run open source software, and I think that's somewhat why you might see me poke a little bit of fun with the Raspberry Pi folks, because a lot of people don't know that while a Raspberry Pi may run open source software, it is not open source hardware.
Yeah.
Whereas BeagleBoard AI is.
Yeah.
And I think it makes sense to choose an open source hardware platform to run your open source software.
And it's not a new endeavor. You've been doing that for quite some time,
Yeah,
right?
I've been doing it so we started in 2008 or so. So what is that? 16 years now. And I know you've been doing some consulting work, right? So I left TI and now I do some of my own consulting work. And so I make with Beagle, I make the open source hardware that I want to use in the projects, right? If whether they're IoT or robotics projects, right? It's the hardware that I want to use in my projects.
Yes. Do you see, like from your perspective, you've been doing that for some time. I would say, is it fair to say you're trying to simplify hardware to really focus on adding the value at the software level?
Well,
and make it
it's
simpler
to get
to
it to
interact with hardware?
the right point of abstraction. I won't say like always simplify, but at least get it to a point where you can actually peel back the layers of the onion to start building some understanding, right? The Linux kernel is not the easiest thing to understand, but it is possible to at least understand it from an interface level without like too much insanity.
Yeah.
And then you have this Git history log, right, that tells you like where did everything come from, right? you can look at Git blame and you could say who did this and why they do this and learn from it, right? So it's for me, it's not always about making like everything just easy, right? Because if you want to make everything completely easy, you have to just hide everything away. And it's about making the easy things easy, right?
Yeah.
But the hard things possible, right? So instead of like blocking off the ability to go further, right? Right, it may not be easy, but I'm going to try to make sure that there are those tools. So if that's like, tool chains for supporting the different processor elements within an SoC, right? I want to try to get all of it out, right? So it's, we want to make the easy things easy, and Linux can help, but like, you want like all the Python libraries and all the other things to kind of make things simple. With the BeagleBoard AI, we've got things in a Raspberry Pi 5 form factor. And so like putting it into a Raspberry Pi system is like mechanically and electrically easy. But then you can go further, right? You can run Zephyr on the R5. It's an 800 megahertz core. You can do real-time I/O. You can program the DSPs. Right.
So it's fair to say, because the reason why I was asking this question about democratizing or simplifying is because I'm seeing many players try to really abstract these underlying layers, offer them as simple APIs, and open up embedded development to other types of developers who are not today super familiar with the specificities, I would say, of embedded development. Right?
Absolutely, right? So just think of it as a computer, right? And I think I've been guilty, if anything, of emphasizing embedded too much. I think, right? So it's just a computer, but so many things in our lives are made out of computers. And my hope is that people can build an understanding of how those things are made so that they can take control over those things in their life.
That makes sense.
And like if you want to do that in Python and MicroPython, right, you can get a BeagleBoard AI, program it in Python, program the microcontroller, the R5, in MicroPython, right? There's a MicroPython interpreter that you just run on the R5, and you can just do everything in Python. And I think like there's a lot of great learning materials using Jupyter notebooks and doing different things that really make programming easier but with Python. But I'll tell you, it's also one of my least favorite programming languages as well.
Especially when you're coming from this world of C, C++, where you have control over everything. Fine control, right?
But I don't have to wonder like how many layers deep did an exception pop up, right? People are pretty decent at documenting. With Python, we leverage Sphinx and the documentation infrastructure for Python a lot, which is really nice. But you find almost nobody documents the exceptions that their modules generate. And so you can just like create a generic capture, and but you can't necessarily like know what sort of things, how many layers deep are going to produce exceptions. That's one of the reasons I don't like Python for like production projects, although I'm guilty of using Python in production projects.
You know what? I'm seeing more of these non-traditional languages, I would say, for embedded development coming in. I'm saying, I'm seeing Rust for good reasons.
Well, Rust makes sense.
Rust is. I'm seeing .NET. Wilderness Labs,
absolutely.
GHI, they're bringing .NET. I'm seeing WebAssembly.
I love
actually we have someone
having LLVM like directly target WebAssembly, right? Means that you can really write WebAssembly in any programming language.
Exactly.
Right. If you want to write WebAssembly in Rust, or you want to write WebAssembly in Ruby, right? I've been playing a lot with the programming language Crystal, which is a LLVM compiled Ruby-like language. I love Julia, which is like a mathematical language, right? So people use R. One of the really common things we see in embedded and stuff that I'm doing is using Docker containers in embedded systems, right? So, or just like you just treat it like you would the cloud infrastructure, and we use DevOps and push
there's this
out
company
containers.
called Atim that we're gonna have another Jason soon on the Here Live podcast. Jason is working on exactly that. leveraging WebAssembly infrastructure to have a container app model for embedded device. But I will not spoil it. It's for later.
But it is. I think WebAssembly is really interesting for embedded devices, right? Because you can contain the system, but you can also make something that actually runs very efficient, right? Because you can produce the WebAssembly and then you can JIT it for your target processor.
Yep, exactly.
And so you see a lot of people, like even like with Zephyr, like taking runtimes and taking like stuff that you can deploy at the end, right, and making it run really efficiently.
Yeah, exactly. So tell me, back to BeagleBoard AI. So AI, everyone has it, and you have it on your shirt. So I have to.
Yeah, I do.
I do have to bring it up. Do you think how is it impacting and changing? We were already doing AI, artificial intelligence. We called it differently, but there is generative AI coming. But to me, that's putting spotlight on real AI, or what I would call boring AI.
Yeah.
That is the AI used to do something, right?
I don't know. I think it's easy for me. Like I want to check myself when I say that, right? Because I say exactly what you're saying, right? Like like for making like real things, this is some of the least interesting AI.
Yes.
But it translates to people, right? AI is now like being something that an average person can experience to make their writing better, right? And I do think we're programming is such a I think when you look at Star Trek and you see people talking computer and they do this that sort of reality isn't so far off, right? And I say that full well seeing how awful some of the generated code is that comes out of some of these I won't name brand names.
Yeah.
But
you won't say Copilot. You would not say ChatGPT. Don't say that. Don't say
that. But it can really generate some junk in code and some dangerous code.
It's to me the way I explain it to friends and family when not in computer science or development. I'm telling them it's a tool. And we will have to learn how to use it properly. They will have to have, guardrails built around it, and we will have to specialize model for certain tasks to make them better.
Well, but I think languages, like today's computer programming languages aren't the best targets necessarily for generative AI models, right? And in fact, it's interesting that a computer is better at expressing English or other native languages in a way that's more comprehensible than it is computer code.
Yeah.
And I think that speaks a lot to the state of computer programming languages today. I think we need to, as an industry, try to figure out how do we get our hands off the keyboard, but continue to program, right? You look at people doing robotics, right? They don't want to be doing robotics at a keyboard. They want to do robotics in contact with the mechanized arms, the different things that they're working within their systems.
And there's another aspect of generative AI that's going to be interesting is for operators. When we're able to bring these models, not LLMs, but small language models, like optimized for the device and specialized in the I would say the literature of this machine, this engine, and whatnot. That's going to be super
contextual, right? And a small language model in a contextual environment, I think, can help you actually do real programming, right? And I think you get into domain-specific languages and things that are much more constrained, rather than trying to have it generate C, C++, right? That are just so wide open that they don't really give you like code that's easily verifiable or actually does what you intend it to do. And I think another one, you look at generative AI. I think some of these time series data, right, and like taking a step back from generating language, but just simply predictive sequences, right? I mean, there's obvious applications in finance stock market monitoring and stuff, but
Yep.
but just failure analysis for all of the various hardware that's out there, and and much lower compute requirements, right? But I think that I think there's a lot of opportunity for us to learn from time series data, and that's one of the big applications I see for BeagleBoard AI
Yeah.
is monitoring time series data and performing local analysis to find anomalies.
Yeah.
And we've had a lot of tools to train models to try to find anomalies offline, but I think a generative AI,
Yeah.
right, is one of those things that can help us kind of bridge the gap of not enough data,
Yeah,
right? So
that's
we're
right.
just sees the patterns over time and recognizes it. I don't want to say like a person, but like a person.
Yeah, yeah. That complex data becomes explained and organized.
And they can find patterns.
Before I let you go,
Uh-oh.
yeah, you're gonna have to.
Did I say BeagleBoard AI enough times?
Yeah, I
Because
think
pi
you
is
have,
irrational.
But I want you. You brought some hardware. Not sure the
Oh.
battery is recharged enough,
Okay.
but you brought some toys.
I
You
did.
like toys.
My fingers.
And we'd like for you to tell me in a few minutes, what is it that you're excited about? How would you say BeagleBoard AI many times? The question is, what is it?
So this is BeagleBoard AI. So
Okay.
it is a single board computer. So it's just a computer. You can plug in keyboard, monitor, and mouse, and you just use it like a desktop computer. But you can also use all of its fun little interfaces and capabilities to put into inventive projects.
Okay.
So this is my mustache camera,
Okay.
which I can't even just like reach the switch.
Okay.
I need to get my. It'll take me a second to go get to try to flip the switch. But this is using computer vision. So I've got a little USB camera here, and then I've got a DSi display, and then the BeagleBoard AI, and this looks for faces and puts mustaches on them.
That's fun.
And then if you use the clicker, it'll upload them to Imager to share them with the world, because everybody wants to see your mustachioed face.
It's awesome. I've seen these students from Harvard, I think, who have been streaming image from one of these like smart glasses up to Instagram, and they used algorithms in the cloud to recognize people, bring data from the people, re-inject that into an app that could read, so they would recognize people in the street and tell them, hey, are you blah doing this and working for that?
Yeah.
And people say, who are you?
This is a very intrusive way that people know that you're invading their privacy, and that we can display the status.
I think that's
live.
funny, but I also think that it illustrates how you can bring AI at the edge, containing in a device like that for doing something here funny, but could become something related to safety, related to interesting scenarios.
It's a prototype for something that would be an interesting scenario.
Yeah.
But
Agreed.
like
Agreed.
so you can kind of work at this as a software starting point and kind of an infrastructure for doing something
and it's
far
on a
more
heavy
interesting.
it's on a heavy lanyard for events as well.
and leveraging the Pi compatibility, the battery is stuck up underneath here, right? So this is using just a off-the-shelf Pi UPS with batteries in order to run, right? So having that common form factor lets you build things really quickly.
Awesome. Jason, thanks a lot for your time.
Oliver, nice chatting again.
Nice chatting with you as well. You might want to grab your adapter, and we'll have the next person coming in. So, stay here.
I'm going to go off to the side and
I'll grab your microphone.
Flip the switch on, see if I can't get a mustache on you. Thank you.
Sure.
Thank you.
So, Pete, we are behind. Hey, Jason, I need your microphone.
Or you need a few minutes?
Actually,
just the microphone.
We have another Jason coming in.
Okay.
Yeah.
Here,
We're
turn
behind.
this off first.
There you go.
You need like 15 minutes?
Yeah, can you send me Jason Shefford? Thanks, man. It's good to see you.
Good to see you in the United States. She's out here.
Everything good?
Everything is good. We're alive. Nice to meet you in person too. Come on in. Let's see. Are you comfortable? Okay. Turn your microphone. We're already live. It's just ongoing.
Hello.
There you go. I will just ask you. You can clip it up there. Usually works pretty well,
I like your real-time setup.
right?
The real-time setup.
It's kind of improvised in terms of the lights and so on.
Yeah.
That works. Not too
Alright.
aggressive. Are you good?
No, I'm good.
Awesome.
Nice to meet you in person.
Nice to meet you in person too. You have something really interesting, company and topic to discuss today. It's kind of an open mic, right? So I'm going to ask you to introduce yourself. We have for now 2 viewers online, so there's not a lot of people.
But it's for posterity.
It's for posterity. It's going to be recorded, and we'll maybe play with the video as well, bringing some B-roll and so on, make some shorts, cut in several portions. But the idea here is to have a nice conversation with IoT fellows, and you're doing something super interesting that I would like for you to tell us about. So who are you?
Professionally?
Both?
So my name is Jason Shepard. I'm CEO for a company called Atom. The way I describe what we do is Docker on a diet.
Yeah?
Yep. The principles of Docker make it feel like the cloud. Otherwise, I call it VMware Micro.
Yeah.
Tiny infrastructure enable you to run containers on microcontrollers up through kind of lightweight CPU-based devices.
Okay. Let me ask you the blunt question of the embedded guy. Why would I want to do that?
That's a good question. I mean, so if you're a traditional embedded developer, you would look at maybe what we're doing is like, I know how to do that. You know, my whole life is about optimizing code for constrained devices and memory management and whatnot. And if you're like M0 class to M3 class, ARM processor, not for us. But there's a lot more people that don't know about embedded C and memory management.
Yeah.
And, I joke like make developers lazy again. just
Too soon.
I know. I'm like,
30 days.
Don't want to get into that.
We need to wait 30 days and we can reuse that one.
Yes. But there's a lot more people that know other languages, that know cloud, know IoT, know AI, and so if you're that person, we enable you to program apps or develop apps and deploy them for an entirely new class of device.
Yeah.
The billions of constrained microcontrollers up to lightweight CPUs, stuff that Linux can't run on. Docker.
And to be honest, like there's less and less embedded developers out there.
I mean, a lot of folks are retiring. They're like, whatever. So that's not, like, you'll see some adoption there, like from the developer on the embedded side. But if it's a cloud person or IoT AI, I'm developing AI and I'm putting it on really small devices. Hey, great! I don't have to worry about all that lower level stuff.
That someone will still have to do.
Yes.
I mean, there's some software underneath that needs to be deployed, updated, and so on, right?
But that's the point. Like the core part of our solution on the device side, we've open source. It's called Ochre. It's part of Linux Foundation. So the idea is, Ochre is like the mini-me Docker. Define a mini-me Docker format, about 1,000 times lighter as a footprint than Docker with Linux. We're working to get it aligned with OCI specs. It's based on WebAssembly. We're working with the WebAssembly community. So make that a standard. We're building on Zephyr from Linux Foundation. Zephyr's got a lot of momentum. It's kind of a modern real-time operating system. It's great. That brings like built-in support for almost like 1,000 boards now. So you rolling in a great community, really active. So you take Zephyr, you wrap WebAssembly around it, and it creates this runtime that there's a community behind. You got to do work on top, of course, but there's a lot of momentum behind just make that work on the device. And at that point, we turn everything into an API, and you just write program to the API. Like when you do an app on your phone, you don't like do lower level device calls for the GPS. You call the API.
Exactly.
And so we make these smaller devices for that. Feel like that. But the other thing is, so we make it possible to run containers on microcontrollers and like true containers written in your choice of language, so cloud native like. But when you go further upstream and you get into Linux capable devices, including I can run Docker, great solution. Of course, you get into Kubernetes and all that. But if you have like a box it's got 512 megs of memory, or maybe a gig, and I could use Linux with Docker. Usually it'd be embedded Linux, but a lot of people are trying to containerize things. With Docker, I've just taken up a quarter of my memory space on a gig footprint, just for the foundation. It's like if your house had a foundation that was like a quarter inch of the way up, whereas with us, 256 kilobytes, it's like basically zero.
Yeah.
So that's all that extra space you can use for apps. So we say it's basically the sweet spot is a meg of memory to a gig of memory.
Okay, so it's
MCU or CPU, doesn't matter, a mega memory to a gig of memory.
okay.
But to your point on the microcontroller side, an embedded developer, I mean, we'll see traction, but we are getting definite interest from people like product managers, engineering leadership that sees, on the embedded side, sees the pain associated with one change makes everyone recompile everything.
Yeah.
And if I'm a shared services group in a global company, I make one change to my networking stack, everybody throughout the company, including the customer, gets hit.
Yeah.
Versus this transactional, if I change my stack, this application on the same box doesn't have to change. We take that for granted in the cloud today. So we're seeing interest on the microcontroller side from that. Someone looking at the big picture and all the pain associated with brute force embedded.
Yeah.
So.
And I would extend that actually. I'm seeing a trend where the technologies from the cloud are coming to the edge. That OT integration into IT is not working. Like these two teams are still fighting. IT is like, there's no way in the hell I'm going to get your IoT devices on my network, and OT guys are just like,
depends on the org, but generally speaking,
And but interestingly, I'm seeing technologies like you were mentioning, Kubernetes. Microsoft has Azure IT Operations. AWS, they have a green grass, and that ability of deploying and managing containers at the edge, heavy edge. But the ability to manage these workloads, these entities, as if they were cloud resources, containerized, I can see that extending. You were talking about compliance with OCI and compatibility with OCI. If an Azure Arc or Amazon equivalent is now able to manage these workloads, these entities, the same way IT folks are today managing mobile apps or other things like that.
Yeah, no,
it's something to say, right?
It's happening. I mean, I've said for a long, I have a lot of little sayings over the years. And I've said for a long time, this stuff needs to be OT trusted and IT approved.
What?
And on the trust side, it's about safe. Like things go boom in the operations world if stuff happens. Like immediate impact to production or maybe even safety or life. IT world, long tail, like massive scale data leak on credit cards.
Totally.
So. And yes, they don't always get along, but we're starting to see this physical separation of concerns, like your controller versus industrial controller versus my gateway that pulls data out, physically different boxes. Over time, as trust is built, you'll start to see them being a virtual separation where you have like control apps running on the same box, and that's going to happen over time, and it's getting there. And it is about working on these technologies that meet all the needs, and that's where you have to cover the full spectrum, because Kubernetes, great stuff, and we're seeing all kinds of cool stuff in Kubernetes and industrial and different markets. Of course, Docker, great technology, but much of what's out there in the IoT sense, like 2/3 of the footprint of devices out there, like IoT devices, can't run Docker. They're microcontrollers. But what if we made it feel the same? I think to your point.
Yeah, it's a matter of one thing that I always say is that in embedded there's no app model. There's no way of defining. Yes and no. At the C level, you have libraries and you have dynamic libraries that you can consider software modules that you're gonna just.
No, it's all hard linked.
But it's all it's all hard linked.
When you compile it.
Now with what you're bringing up, you have an app model that is very similar to what is used in the cloud and in other areas. And that allows us to have a more dynamic embedded device and domain, right? So that's something to say about the fact you are bringing an app model. I know Wind River is also trying to do some containerization on microcontroller. You're not the only one, but you're doing that with WebAssembly, which allows to have different language used to build the application, the workload. So it's pretty smart, pretty different.
Yeah, and we contributed. I mean, there is a bunch of interesting work going on and some really good companies behind it. But the fundamental difference we believe in is the engine has to be vendor neutral open source. Not open source. There's people that say, oh, look, my stuff's open source. But you host it.
Yeah.
Big difference then. I put it into Linux Foundation where there's vendor neutral governance, open meetings, it's all transparent. And so that way, anyone could take, so Project Ochre, which we just seeded, and now it's going live. We just did another code drop this past week, and we're doing our first TSC meeting, the Technical Steering Committee meeting, which has folks from Sony, Mediacura, and Emerson on it, and like really good names. We're kind of building this consensus around that base. Mm-hmm. We commercialize it and we sell our hub, but I'm not so sure as an OEM that I'm going to be like, hey, let me base my entire infrastructure on this proprietary stack from a small company that if they disappear, I'm starting over.
Yeah.
And so big believers, like, go drive a standard with that open component. Our job is to make our commercial adaptation of it better. Okay. But anyone, have at it. Go build it.
So people are ready, like it's ready to be used, ready to be tested?
Yeah. So there's kind of different ways to engage. So one is go to the Ochre project in Linux Foundation, download the code, vote with your keyboard, write code, fork it, go do your own thing. Cool.
Yeah.
We'll be launching an Atom developer program where you can use our UI and all of our bells and whistles with the runtime. Kind of Q1 next year, maybe March timeframe. So that's where you can come in, party a few, maybe a couple devices for free, get the full experience. With Ochre, the runtime on the device, you're doing CLI, painful, it's companies make money off the IDIs, I call it. Manageability, security, usability, scalability. You don't make money off the basic stuff. So you can go to Ochre, self-service, go to town, come into the Atom and Developer Program to be launched next couple months. Or if you want commercial help, let's do a paid POC,
awesome.
Do production, whatever. But
we'll put some link down there in the replay of the video. Thanks a lot for your time today. It was good to meet you in person.
Yes, it's been, it's
appreciate that.
Always seeing everyone on screen. Yeah. Always great.
I'll need your microphone.
Cool. Oh, I'm going to take it. I'm going to take this to the bathroom.
This will be funny. Hey guys, so we're behind, so he's next. Yeah, come on, Pete. Well, you're welcome to take a seat. Okay, man. Just be yourself. I have no clue what I'm going to ask you. We'll see.
Let's see. How do
you have a little clamp, or you have the magnet, but the ideal is the clamp here. You can clamp it in.
Probably going to hang my lapel a little bit.
Is it coming? Let me help you.
Oh, there you go.
Oh! Oops, sorry guys. Did I just totally... let's try on the shirt here. Actually, it's even better. Oh, don't move. Good. Okay.
Hey.
There we go. 1, 2, 1, 2.
Yes, you're good.
Pete,
testing.
How are you, my friend?
Good.
Okay.
Doing all right.
So we have 10 minutes.
All right.
The idea is to do this live IoT show.
Hello.
We're not so many right now online, but that's okay because we are recording.
All right.
And we'll have that published later.
Friends and family.
Yeah, we are at Embedded Friends and Family. It's my brother and sister.
Cool. Hello.
I know they're not even online. Damn it. They don't care. Maybe my kids? No. Fine. Forget. But so we are here to discuss what's going on here at Embedded World. First edition of Embedded World in the US.
I know.
That's fantastic. And your role at the TinyML Foundation.
Yes.
I mean, people know you for having been at Microsoft, leading all the work around silicon vendors and the partnerships and so on, and more. But you have this new role now, and I would like you to tell us a bit about it.
So I've been running the TinyML Foundation for about 6 months.
Okay.
And it's a great community. It's a worldwide community. We have over 100,000 students that have taken TinyML classes around the world. We have, professors from universities around the world. We have industry support from major semiconductor partners and startups and software companies and model makers and data sets. And so it's just a community of people getting together, trying to figure out how to do AI on the edge, or what I call connecting AI to the real world.
Yeah, and just to be precise, for those who are not familiar, we're talking about AI, not AI, right?
What else is there?
There's one AI everyone talks about these days, with generative AI.
Oh yeah, that.
So it's not excluded, but we're talking about AI in general, right?
Yes. And it's really about AI outside the data center, and AI, like I said, like in resource-constrained environments or in the real world. You know, that's affecting agriculture and water systems and healthcare and safety. And there's just amazing innovation going on. We had 6 talks today at Embedded World, covering everything from neuromorphic computing to, you know, in-memory computation to, you know, how to run small language models on like Cortex-A brownfield systems. Like really interesting stuff.
Did you find people being like familiar to embedded and so on, being surprised that you could run such sophisticated model on tiny hardware like that?
I think so. I mean, I think certainly there's been like anomaly detection type of like, you know, isolated forest kind of DNN type stuff for a while, and it's kind of low power computer vision for a little while. I think the stuff that's happening now, especially with like transformer based architecture, is new. And we had someone demoing that today, how you could run, you know, a fairly focused, you know, RAG-based LLM or SLM, you know, on a pretty disconnected piece of equipment, and talk to it, you know, and talk to a piece of equipment and say, "What's wrong with you?" And the equipment's like, "Oh, my spanner is broken," or whatever.
Please lie in that chair and tell me what's wrong with you.
That's right. Please tell me what's wrong with you. But no, giving voice to a lot of these machines, you know, is really fascinating. Or just talking to your car and saying, you know, how do I turn off the regenerative braking on this thing? Yeah. It should just tell you, oh, do this, you know.
And you have a context.
Yes.
You have a context, which is the machine, where it's run, what it's for.
Right.
And this thing will not tell you about the weather.
No, and it's not going to give you a poem about cats or whatever. It's not trained on the entire internet. It's trained on a focused set of data.
And it will do that right. It will actually be super precise, no hallucination.
It will not hallucinate.
Yeah.
Will not make up answers about how to turn off your regenerative braking. So, and in fact, we have an event, a free event, October 17th and 18th.
Okay.
People can go online and hear like 2 days worth of talks. Go to tinyml.org and register for free. We're going to have 2 days worth of academic researchers as well as industry folks talking about generative AI on edge equipment and everything. It's totally the state-of-the-art stuff. So memory optimization talks from Korea, and you know, model optimization talks from Abu Dhabi, and you know, all kinds of stuff. So it's pretty cool. So if people are into the how do you do generative AI on these kind of edge equipment things, that's going to be a lot of fun to learn.
That is. Like that. You're having fun in your job, man.
It is. It's a lot of fun. Every day I like, it's not only cool because it's like the people are cool and interesting, but the tech is moving so quickly that every day you can't help but learn something that's going on. So.
You get a chance to get your hands a bit dirty in code and so on?
A little bit. I mean, I play around with some stuff, but you know, it's just, I'm just in awe, especially some of the PhD students and other folks that we interact with.
They're so smart.
Oh,
it's just
incredible.
Like, maybe I should not touch that code.
I feel like a little bit of hope in the future, because like these guys, these folks will figure it out somehow.
Right.
But
technology is in good hands.
Yeah. But the show today was great too. So I just like nice to see everyone here, and you know, everyone's got interesting backgrounds that come to this space from different angles, and so it's pretty cool to see.
I was, related to my previous question about were people surprised. Do you feel like there is a lot of convincing for you to have them convinced that that's where things are going forward? AI being at the edge, or being actually, the way I like to say it is like AI is being distributed.
Right.
And it's not new. Remember, robotics has been about distributing intelligence across the system of entities. And so here we're talking about doing similar things, right?
Well, I mean, what is it? William Gibson once said, the future is here, it's just not evenly distributed.
Yeah.
And so a lot of the stuff that's happening, you know, there is a lot of noise about, you know, OpenAI and Anthropic and all the $100 billion data center, blah, blah, blah. But, you know, we consider ourselves sort of the flipping that script and saying, well, there's actually this other AI that's happening in small devices that's actually having more impact and using less resources. So less electricity, less water, less concrete, and having more impact on people's actual lives. And
Gotcha.
maybe it's not as glamorous as like a fake girlfriend that sounds like Scarlett Johansson, you know. It's probably more important.
We'll see fun stuff coming up.
Cool, man.
Pete.
Good to see you.
Thanks a lot for your time. Good to see you.
All right.
And see you around the next
Yes.
2 days anyways. And later on, you know, once we're done with that,
Sounds
I'll
good.
leave you guys. Don't forget to give me your mic back.
Yes.
And if you can send...
I will not
Was it
steal your
Jap?
mic.
Was it Jap that was behind you? Who was it? I think it was him. Yeah. Yeah. That's it.
right.
Send him more. Thank you, man.
Who should I send it?
The guy was... I'm sure you... Yeah. Okay, so we'll get going with our next guest here. About to get ready. Hey, how are you? Yeah.
Nice to meet you.
Did I say it correctly? Is it? Yep.
Yeah, yes.
Yeah. Okay. Let me just attach that here. And we're good to go.
Had my beer.
Yeah. Thanks. Yeah. I can hear you.
Good.
I didn't have my beer yet myself, so.
You didn't have a beer?
No, not yet. I'm on water. That's okay.
Here you have an antenna.
Oh, thank you. I have an antenna.
We're gonna talk about it anyway.
So that's what we're going to talk about.
Yep.
And it's not about the round thing. It's about the little tiny red thing you don't see here.
And don't tell nobody, but these are secretly private trackers. So after this, you will always know where
you'll
you
know
are.
exactly where I'm at.
Yeah. We give them out on the show all the time.
That's smart.
Thank you.
That's dangerous too. So tell me, who are you? What are you doing in life?
Oh, that's a big question. My name is Jaap Groot. I'm Dutch. Today I'm running an antenna company.
Okay.
But I've been in telematics, navigation, communication all my life.
Okay.
You can see my life has been a little bit longer, given the gray hair. So yeah, a little bit of
You're good.
experience.
Looking good.
Yeah,
Looking
yeah,
good, man.
yeah.
So, what is the problem you're trying to solve? 'Cause I've seen some solutions that were bringing multi-radio connectivity on devices. Particola has a solution. There's Walter. There's like different players in that new pond, I would say. So, what is it that we're trying to solve by putting together different radios? Isn't an embedded device specialized and should just need one type of radio, one type of antenna?
No. I think there's plenty of antennas.
Okay.
And there's nothing wrong with other than red antennas. There's a lot of other colored antennas too. So the problem that we're trying to solve is mostly on the off-the-shelf antenna side.
Okay.
Half of the market is custom. People make their own antennas, which is brilliant. And if you have the volume, you should certainly give it a shot. Because it's not easy. But half of the market is off-the-shelf antennas. And in that off-the-shelf domain, the use of the part, because it's a ready-made part, is difficult.
Okay.
And basically what we're trying to do is make it as simple as Lego. By giving people a manual, you open the box, you follow the manual, and at the end of the, however long the manual is, what you're talking about is multi-band, cellular, with maybe no NTN, and by all that stuff, that's a big box.
Okay.
That's a plus 10 years old box, right? That's not for starters. But anyway, if you follow that manual, you will end up with a device that can communicate.
Yeah. Okay.
That's the idea.
Okay, good. I like that. So, since very much necessary, what is the typical application for this tiny antenna? And once again, we're talking about the antenna, but it's not just wires, right? There's more than just the wires for communication here. You have actual electronics in there that will interact with a chip, with software on that chip, and so on, right?
Absolutely. So at the end of the day, the RF system, as they call it, consists of the radio module, which could be Bluetooth, Wi-Fi, cellular, satellite, anything, and an antenna.
Okay.
But they go hand in hand. So in the ideal world, it would come from one supplier. There's only one that is trying that right now, which is a Chinese supplier, which is kind of struggling.
Yeah.
So all the rest of the guys have the modules, and nobody has the antennas. So now you get into a complex situation where you're buying two building blocks, two different sources.
Yeah.
And I can tell you, anybody that buys a new car doesn't ask about the tires. This is the same in the module world. Everybody who buys a module doesn't ask about the antenna. That's an afterthought. So at the end of the day, yes, you need to look at the whole system as a setup, and what you need to make sure, because maybe you're underestimating. I think IoT is not what it's all about. It's wireless. And wireless includes all of a sudden things like navigation systems, which are connected, glucose monitoring, which is connected. Of course, smart buildings, smart this, smart that. The biggest markets today that are really doing volume is smart metering. So all the utilities, and that goes city by city or country by country. Those are big volumes. The second one is tracking. A lot of things are being tracked, and more we see labels coming to the market. So smart stickers, let's say. And last but not least, wearables. Wearables are very popular. Health. Exactly. Everybody.
Consumer or health.
Lone worker also for wearables. So all that stuff. And the good thing is that the market is, there's no S curve. This, so the market is growing with a compound average growth rate of 15-20%. Let it be. Everybody is kind of yawning about analysts who said 10 billion or 20 billion or whatever. It's still multi-billions.
Yes.
And it's not going to stop. So that data will continue to be delivered to the cloud. That data will continue to be delivering value in terms of being analyzed. Whether you use it through a spreadsheet, ML or AI or whatever in between, it drives value. And I think that's where we are at in the crossing the chasm now. Forget about all the components, they exist. Some of them don't work together well enough, so we need to talk about standards and stuff. But bottom line, the products are there. Let's drive the value for the customer.
Perfect, let's do that. Did you, well, you say your last name, but that's the name of the company as well, right?
No. My last name is Groot, which is a character from a movie. Maybe I won't. But no. Ignition is the company.
Ignition is the company.
And Ignition stands for igniting devices, sparking energy ions into the. And that's what we do.
Love it.
With a small antenna.
Well, I learned something tonight.
Good.
Perfect.
Good. Thank you,
Thanks for your time, man.
Have a good evening.
Have a good night. Enjoy.
And catch up with Alistair.
Yeah, definitely.
Thank you.
I need your microphone back.
Oh, yes. Everybody forgets.
Everyone runs, because it's so light.
All right. Man.
Thank you.
See you later.
So we'll try and find our next guest. Stay online, and we'll have someone else coming up. Sorry for that. I'll be back. Yeah, long press. Like all devices, this kind of. You can clamp it there.
Oh, there you go.
And it doesn't need to be too high. There you go.
Cool.
There you go. Looking good. Let's see your microphone. Perfect. You're
Okay.
good. You're framed. You're big, so you're good. We're trying to stand still. How are you, my friend? Long time no see.
Very well indeed. Very busy. We're
Very
here
busy.
for, like a management offsite, which happens to coincide with Embedded World. So.
Okay. So let's do the traditional introductions. Who is Alistair? And you obviously are working for Blues.
I am.
These
I'm
days.
fully branded. I like to say.
Tell us about yourself, where you're coming from, what you've done so far, and then we'll talk about Blues.
Okay, so Alice Fulton, you and I first met at Microsoft, where I spent a bunch of years. I think about 8 actually in total. Starting with building an incubation project that over many iterations and spins, as is the Microsoft way, turned into the beginning of Azure IoT.
So we found Brandon. We'll have you online if you want after.
I was given my spot. You don't want both of us on here.
I don't know. You tell me.
He's much more interesting than me. I mean,
that's not true at all.
Yeah, we'll do another longer one together offline after the event.
Yeah,
awesome.
That sounds good.
Awesome. See you later.
All right.
So yeah, I spent 8 years at Microsoft, a couple of years starting what turned into Azure IoT. I went into Windows Embedded and spent 2 years persuading Windows Embedded that the future was in connectivity and intelligent devices. And then spent a couple of years in M&A in the Cloud and Enterprise division. And then latterly, a couple of years in the developer tools business, helping build developer tools for embedded IoT devices. I left in 2018 or so and went into Hitachi, actually as one of the founding team that built the Hitachi Lumada industrial IoT platform. Super heavyweights.
Rob Tiffany.
And Rich and a whole bunch of folks that, the fellow travelers. And Lumada was really a product designed to be incorporated into Hitachi's main product line. And that's exactly what's happened. It helped that the sponsor, my sponsor is now the global CEO of Hitachi, and he kind of took that digitization initiative and really used it to turn Hitachi's strategy around from being a machinery provider to being a service/solution provider, which is a much overused term. I left Hitachi. Actually, over the years, I started out building solutions that you call IoT today, but then were called machine to machine, even before I went to Microsoft. And before that, I was in cellular, like many of us. But gradually, I went from solutions to building platforms, and then I went down even deeper into silicon. And so I joined a company called Centec to run their IoT division. Probably the most, I'd say, notable/famous product that we brought to market was LoRaWAN. So that was a technology that Centec invented back in 2015. I joined to take that business forward into what is now the leading LPWAN globally at this stage. Left Centec after the Sierra Wireless acquisition and joined Blues. And Blues is a company founded by Ray Ozzie, who coincidentally was the first executive who gave me seed funding and the nod in Microsoft way back in the beginning of Azure IoT. And what Blues does is we are focused purely on solving one problem, and that's the problem of simply connecting any machine to the cloud and rendering an intelligent device. And we do that by providing a multi-radio, abstracted hardware solution that hides all of the complexity of cellular, of LoRaWAN, of satellite behind a JSON API. So if you can understand JSON as a developer, you don't need to understand AT commands. You don't need to understand how the device actually works. You just need to be able to write business rules in JSON and the device is connected. So we target companies that make stuff, primarily. Big machinery, HVAC units, you name it, full range. We're 6 years old. We started out with a very product-led growth model. We then built an enterprise sales force a couple of years ago. And one of the things I've been focusing on is building a partner ecosystem. So at the end of the day, what we build really is, it's a sales tool for partners. If you build solutions and your customer says, how do I connect it? Blues is the simple answer. And I also, my other, I'd say, positioning to partners is we sell time. We sell time, reduced time for development, more time for you as a partner to be able to take on more business, to deliver more value to your customers by taking what's often a 12, 18-month timeline to actually figure out how to build a chip-down connected device.
And then get certified and then go through all the ISPs and so on to get,
So the hardware we sell is pre-certified. It does everything you need an embedded device to do. It connects to a simple M2 connector. You can swap one card in and swap another card in without code changes, and it includes hardware. It includes connectivity, so it comes with 10 years of connectivity in the price.
So for now, cellular only, or do you have
No, we have cellular, all the flavors of cellular. We added LoRaWAN actually about a year ago now. We added satellite a little while after. Same business model. So satellite comes with 10 years connectivity. It's narrowband satellite. And we're gradually expanding the portfolio. not with the aim of covering every single option, but with the aim of providing the right set of tools that customers want to choose between based on business need.
Okay, and so imagine I have a device, I want it to be, for example, an asset tracker. It's going to be attached to a container. It's going to go out on the road. While it's on site, I'm going to have maybe Wi-Fi or cellular coverage. I'm getting out in the wild, maybe no longer any cellular connectivity there. Switch to satellite, then get back onto cellular range, back onto Wi-Fi range. Everything is transparent from the application perspective running on a device. You have APIs, I guess, that makes it transparent. As in
One API.
Send message.
One JSON API.
Okay,
Same message, same code. You need to make some tweaks as you shift in the application logic as you switch from cellular to satellite, say. You may want to make some different choices about power consumption if you're running a battery. But the aim is that you as a developer should be able to make business decisions about how you want the device to function without having to figure out how to actually make the hardware work. Because that device that you described, if you're actually trying to build a cellular device, so you buy a modem from a Quectel or a Telit, you want to add LoRaWAN to it, so you go buy STM's products, or you go buy a chip down from Semtech. You want to add Wi-Fi, you want to add satellite. That is a massively complicated development project. And with Booz, you can get through that process in a matter of weeks. We've seen customers build a POC in quite literally 2-3 days to go from concept to a working device, albeit not production ready, but a working device. And that, honestly, I've spent a long time, in fact most of my career in this space, and I've gradually come to the realization that what you do with the data is a solved problem. There are multiple tools out there. It's becoming increasingly easier with AI still to actually derive value from the data. AI is a much misused term, but a lot of time it's machine learning. But you can use these tools to extrapolate and dissect the data more rapidly than you could otherwise. So where the data's going and what happens to it is a solved problem. The time I see customers spending today is still on what we all in the IoT industry, we all consider this to be a solved problem. When you and I were at Microsoft, the data was just going to show up in Azure IoT. We didn't have to worry about how it got there. That's the easy bit. And the reality is that from a technical perspective, it's not easy. From a business perspective, it's not easy. So, I mean, one of the things we've done with cellular and satellite is take away the need to have a contract with the provider. It's just included in the cost of the hardware. Even the administration of payment, if you're building a solution that you're selling to customers, you used to have that conversation with your customer where you said, I'm going to sell you this thing, it's going to cost you, I don't know, $10,000 per machine, and then you're going to have to sign up a contract with, Verizon or Vodafone, or, good luck with that, call me if you have any problems. And that's just complexity that customers don't need. They want to just get the damn thing built and get it working. So it is a gradual realization that actually the problem that we needed to solve was simple all along, at least in its scope, but hard in its reality.
So I asked a question to a few of the previous guests, and it might sound tangent or like going in a different direction, but do you see connectivity and AI having any freaking relationship or helping each other or whatnot? We talked about connectivity allowing to bring data somewhere so we could train models. Now we are talking also about running AI down there on the devices. Do you see connectivity as being like fundamental for making that distribution of AI possible?
I think of it in yes and no. I think of it in slightly different terms. I mean, if you look at the various technologies that have arrived over the course of the last few years, AI is one of them. It's the one we were all talking about. Everyone's scared of AI because they've seen what ChatGPT can do and they read the scary headlines about how it's going to put everyone out of a job. But if you look at it more broadly, there's AI, machine learning, there's high bandwidth networks that are getting increasingly cheaper. There's things like RISC-V and GPUs, which in some ways were the payoff from the cell phone, the smartphone wars. They spun out of that. And if you look at that concentration of different tools, I think that combination is starting to converge in much the same way as technology started to converge to drive the adoption of the cloud. And what that is driving is, when you look at the base of industrial devices around us, devices that are in large part responsible for creating human-caused climate change, those devices were designed in the industrial age.
Yeah.
They were modestly augmented when we moved into information age, but they are still way behind in terms of capability to act as intelligent machines. And what I mean by an intelligent machine is one where the edge and the cloud, the machine and the service is indistinguishable.
Yeah.
That the device manages itself, either using Edge AI or allows you to optimize how it's behaving using some central form of analytics, sometimes AI, sometimes machine learning, sometimes simple rules engines. But it is all of those technologies together, not just AI, connectivity, low power compute at the edge, all of those things together are probably the best chance that we've got to meaningfully change what is going to continue driving human-caused climate change. Because these industries, and it's the dirty industries around us, mining, power generation, distribution, manufacturing, things that are essential to human life. That if we don't actually deal with the root cause, it doesn't matter how many new devices we come up with that are connected and smart. Honestly, I hate to disparage consumer IT. Consumer IoT is not going to change anything. Unless we figure out a solution to go back in and retrofit all of those old factories, we're screwed.
Yeah. Awesome. Alistair, thanks a lot for your time tonight.
You're most welcome. It's always a pleasure.
Great
nice
catching up. And we'll catch up with Brendan as well sometime soon on the IoT Show. Don't forget to give me your microphone back.
I get to keep this. This is not
a gizmo.
This was a giveaway.
Not a gizmo. Or then you go to the bathroom and we'll hear you. Cool, man. Good to see you.
Indeed.
See you around.
Who's next? You got him next. How is business?
Business is good.
Yeah, good.
And I will just go right there. I'll catch up with you down there. Okay. Hey, Mark.
How are you?
Oh, you're a friend. Good to see you.
How's it
So
going?
we'll have you after Ellen, right? It's good. Well,
No. She's coming.
Yeah, she's coming.
Just saying hello.
Hey, man. How are you? So that's okay. You can come after Ellen.
Yeah.
We have time. I'm here all night long. I didn't get a beer though.
What do you need? What
Later on,
beer?
after. I wanna keep. Oh, exactly. We don't do that. Okay, we're waiting for the next one, and we'll get going.
No, I'm just gonna.
It's
We've
good
never
to
met
see
in
you.
person.
No,
It's
we
good
have
to
not.
see you, and it's nice to meet you.
Good
in
to see you.
person.
Same here. We'll talk after. See you. Ellen, thanks for coming.
Yes.
How are you?
I'm so excited to see you.
Yeah. Oh, okay. So let's attach that. You have a little clamp. Yeah, you should. Yes, there you go. Got it. And we're live. So we have a few people watching right now. You can say hi there.
Hi.
And but we're also recording. I'll cut things in chunks, and then we can republish that, 2 shorts and whatever.
Okay.
And the idea today, Embedded World, is to say hi, to share a little bit about what you guys are doing, Factor, and talk about what we want to talk about: AI, IoT, a bunch of things, right?
Sure.
What do you feel?
Sounds great.
Awesome.
Yeah.
Well, thanks for coming. Who are you? What are you doing?
Well, my name is Ellen Boehm, and I'm the head of IoT at a cybersecurity software company called Keyfactor.
Okay.
Been there for about 5 years, and before that, I was in smart home and smart cities product development and engineering. So I have an IoT product background, but now I'm totally into cybersecurity when it comes to securing devices and creating secure connections between those devices and whatever they need to talk to.
Yep.
So that's a little bit about
Interesting.
me and what I do.
So let me ask you. I was at Microsoft for a long time.
Yes.
And I left Microsoft last year. Companies like Microsoft, they work on the next 5 to 10 years. And so when I was engaging with developers about IoT and embedded devices and so on, to me it was a little bit of a given that things were connected, that were going beyond just the asset connected thingy. But actually I realized in the last year or so that companies are still trying to connect things, and that security is one of the big blockers that basically slows down that connectivity. They see value in connecting devices, gathering the data, extracting the insights, but they're struggling at identifying really how they can do that in a secure way. What would you say are the main things, and with the work you're doing at Keyfactor, that people need to understand to not be scared about connecting devices, what are the main things they need to think about to secure all of that, to make sure that they can go on to extracting the data, analyzing the data, taking action, changing the business models and so on?
Yeah, there's a lot of things. I think some of the key points, let's start with firmware. So first of all, if you are writing your own firmware, you should make sure that you're signing that code, and when you push updates to your fleet of devices, you should have those devices validate where the code's coming from, so the origin and the authenticity, and you can do all of that with verifying signatures. So that's like one small, easy tip. I think if you are a system integrator and you're compiling a bunch of different devices, you have to understand all the software inside of there. Is there any open source? Even if it's not open source, who wrote it, where did it come from, and then understand critical vulnerabilities, and then having sort of an ongoing process to manage and monitor that. And then maybe a third thing that we talk about is, again, being able to connect to your devices remotely via a secure channel. So an authenticated way to connect to your device, and we do that with certificates. So every certificate or every device should have a unique certificate-based identity. We've done this in the enterprise for decades, and now we're seeing this come up more and more in IoT. So it's really as basic as that. Have sort of a birth identity and then an operational identity for how you connect to it.
And something that many, if not all, of the IoT platforms out there try and provide, right? The notion of a device identity and this generation of the cert that will go onto the device to allow encryption and so on. But very often I've seen customers saying, but who's the authority that will create that certificate and will authentify it and so on, right? I might not want to trust that one cloud platform, because they're not independent, and I'd like to have this third party. Is Keyfactor actually doing these kind of things?
Yeah, so we can provide a trusted root authority. And it can be dedicated to your company. So I know there's a lot of different ways to do it, right? You can get your root from a cloud platform, or maybe even a root can come from a chip level, which again, we're partnering with several of the silicon vendors to be able to enable that. So I think it's a company decision about what you want that root identity to be, and that root of trust then creates everything. You can create an infrastructure based on product line or product group or end customer, but really that's really what it is. And so trusting the root, who owns and manages that, and then who has access to that is really, really critical. But then in that also regard, if someone gets access to your root, you have to have a way to update it. So that's also important. So how do you have a way to then have all your devices to be able to refresh their crypto even while they're in the field? So having a method to be able to do that is super important.
The scary thing of like, oh, I'm going to be disconnected because my credentials are being revoked and renewed.
Yes, how do you do that? We also talk about that in terms of post-quantum crypto. So that's a whole other topic about how when post-quantum computing can crack the encryption algorithms that we have today.
How do you scare people?
It's almost Halloween in the US here, so I'm getting ready for that. But no, it's something real, and we have people, very, very smart guys at Keyfactor that have been following the NIST standards around post-quantum crypto and implementing that into our products. So we're testing even like dual algorithms. So you can have a classical algorithm and then a post-quantum algorithm sort of ready to go. So that's a little bit more future thinking, I think important for critical infrastructure. So
there's something to say about the fact that security itself, cybersecurity is for IoT becoming something critical, because now things are beginning to be connected and you're sharing with an infrastructure that might be public, data that is critical to your business, right? And so cybersecurity is becoming really important. There are a set of regulations that are coming in to try and help enforce a certain number of things, but it's super hard to understand. And I'm wondering, is Keyfactor helping companies as well navigate these new regulations, this new context that manufacturers have to take into account?
Yes, I'd say most of our conversations with our customers are about that. So they understand Cyber Resilience Act in Europe, right? Going into effect, there will be fines if you don't comply. And so part of it is breaking down what they say within the CRA which again talks a lot about authenticity, talks about signing code, talks about having cryptographic risk assessment, security risk assessments. So I think we are working on that.
Yeah.
I also am part of the IMC, which is a sort of a council of a bunch of different companies, and we're trying to do a similar thing, is understand what guidelines and standards are out there, and then regulations that are driving decisions by industry, because there's several of them. There's automotive standards, there's medical standards, but then I think the CRA is the one that we seem to be talking about a lot. That's driving a lot of behavior. So we got to take care to
People are freaking out.
Yeah.
They've seen GDPR coming in, and they realized how expensive it was to implement something as simple as GDPR.
And this is more complicated.
Yeah, this is a high level. You need your key factor buddy to help you understand all that. I'm saying that jokingly, but at the end of the day, IoT is becoming a domain where you have multiple disciplines that you have to take into account and to put together. There's the embedded one, there's the connectivity, there's the cloud, there's security and cybersecurity. And so you have to really go talk to the people who know how to do each of these things to really do it well. Like, I don't think anyone can really, apart from some companies that can hire all the talent, but I think it's a matter of partnerships and understanding who can help you implementing your solution, right?
I completely agree. And that's why I really like coming here to Embedded World and in Nuremberg as well. A lot of partnership discussions, because I think we all realize that the ecosystem is what's going to help make this successful. And I don't think you want to rely on one single company to solve everything anyway. That's really us coming together and saying, you're really good at this and you're good at this, and then kind of putting all those ingredients together to make the right recipe. So.
Also, Ellen, that was great.
Yeah. It's so nice to see you again.
Yes, definitely. It's good to see you.
Thank you.
I'll take that microphone back before you leave. And let's stay in touch and try and do that again real soon.
Right.
Awesome.
Take
See you
care.
soon.
Thank you.
Bye. Okay, we are moving on. So we'll be moving on with Chris here from Goliath. So it'll be maybe one of the last conversations of the night. So thanks for those who are still online. Thanks, Peter, for the nice words about the host of the show, my friend. And thanks for everyone who's online.
Hey, Libby.
How are you, Chris? Good to see you in person.
No,
You know, I think we met in person a long time ago. I don't know.
Maybe a long time ago.
Yeah.
Yeah, definitely.
I'm going to test that.
Oh,
You
I know
can
these.
test
I have one of these
later.
over there.
Yeah.
Yes.
There you go.
Okay.
Familiar with these ones. They're pretty good, right? That's the first time I'm using them. I love them.
Oh yeah, I love these
love
things.
them.
Oh, this chair makes me feel regal.
Right?
Yes. Bring me all your IoT things.
Let's build things together.
Yes.
Awesome.
Excellent.
So, Chris, who are you and what are you doing?
I am. My name is Chris Gamble. I am the head of hardware and developer relations at Goliath, which is an IoT SaaS platform. Basically, our product is a cloud-side set of servers, but really enable hardware, firmware, and cloud. So basically making it so that it's really easy for hardware developers and firmware developers to get embedded constrained devices to talk to the internet.
Yep.
As you know, not the easiest thing.
Yeah, not easy. And we had Zach on the show recently, on the IoT Show, to describe Goliath and so on. I like him. He's super excited about the thing and so on.
Yeah.
I'm wondering, like, from your perspective, you guys have a lot of news these days.
Yeah.
Yeah, and the industry at large is to me aiming towards having different problems solved and these different solutions integrated into something broader, right? So Goliath is solving part of the problem.
Yep.
You're not doing everything.
Nope.
All the platforms that try to do it all failed. Like,
Oh yeah. Well,
like
yeah.
yes.
Yes. Yeah. I think that's
I
right.
remember one of them at Microsoft
Got it.
that didn't go anywhere.
Got it.
For good reasons. It's because that doesn't work. You cannot
Yeah.
build something that is
Engineers
generic
are kind
enough.
of opinionated. Have you noticed this? They want to do things their own way.
To be fair, it could have worked, but it would have been super expensive.
Yeah, that's
You know,
it. Right. Right.
So what is it that Goliath does well? Like, maybe it's going to be some repeat, but what I want to hear from you is what's new, what's the latest about Goliath
Got it.
that will interest our audience.
Got it. Okay, so Goliath does constrained really well. And we do that by implementing on our server side. Like, this is all, we also make it invisible to the user, right? That's another thing. Like, you can dig under the hood. It's all open source on the firmware side. Our hardware is open source. Our cloud side's all documented. But basically, if I want to make a efficient call from a cellular device, like I'm showcasing here at the show, to the cloud. It's literally like Goliath stream.write. That's the kind of level of thing it is. It's not actually that, but it's that kind of level of API call. And we target custom hardware in doing that, right? So being able to retarget that same simplicity of the SDK at a wide range of things. We build on top of Espressif, ESP-IDF, on top of Zephyr, which targets increasing number of hardware, and a couple of bespoke platforms. And we actually have a Linux thing that we're working on now too. And basically making it easy so that when you do kind of boot up the SDK, you have network connectivity, you have that, what I call a thin, precise pipe to the cloud, and then you get all of the internet-y type stuff. So you get over-the-air updates, you get to pipe your data back and forth to the cloud. You have security, a single security credential that allows you to unlock different services that are on the outside. So I'm not sure that was a very precise answer, but...
No, I think that's good enough, because that allows me to move on with the conversation here, because I'm wondering, so devices are not always connected.
That's right, yep.
Right? And so when you just mentioned things such as firmware updates and so on. Would you agree that this is a very complex domain, like at scale, to do at scale?
Sure.
Is Goliath equipped? Hey, buddy, good to see you. So we are live. We're live now. If you want to join after, you'll be good, man. Don't worry. That's Leonard. That's Leonard.
He's coming in the foot shop. There we go. Oh my gosh. Oh my gosh. Guys, you're in Texas. Please throw him up the Texas way. UT. Come on.
Yeah. So devices are not always connected. Super hard to know that your fleet of devices received an update and so on. And what is this strategy? What are the things that Goliath is doing to make sure that the customer was saying deploy, has it right?
Got it. So just with OTAs or kind of more broadly? I mean,
let's start with OTAs, because that's something that
Sure. So on our side of things, say you kick off an OTA update, we just launched something called cohorts. It's really easy to target different binaries being packaged together, but also being able to target different regions, and it's basically an evolution of kind of how we are already doing things and a new UI. But basically, then, so you release a new. Do a new release to your cohort. So you're saying like all the devices in Austin currently that are eligible for an update, send them out. We have precise logging all the way down to the device itself, so you can always dig in, see where it is, see if it's connected. We have reporting back to the cloud. So being able to like click down and kind of dive into each individual device and say, oh, this one actually has a success message. It's reporting its newest firmware. It's reporting, idle firmware state, that sort of thing. That's really made it all possible.
Okay. Same question as certainly for most of the guests who came today. AI. So what is AI?
It's out there.
What is? Yeah, it is out there, and it's scary, and it's not, and it's been there for some time.
Yeah.
Are you, with Goliath, making it easier to deploy models, to manage models? Are there specific things that Goliath is doing to help customers do that?
Yeah, so we had an AI summer where we were kind of developing stuff in like an 8-week period where we were trying to kind of really ramp up our capabilities. Some of the things that we did, so we utilized our pipeline feature. So basically, data that's coming through that precise pipe from a cellular device, perhaps, up to the Goliath cloud, probably wants to go somewhere else afterwards. It can stand Goliath, but it's not that useful if it's a photo, for instance. So now imagine you have an embedded camera talking through a cellular embedded modem, up over CoAP to Goliath, and then that photo is on Goliath, but it can be routed out to an S3 bucket, right? And so we set up a pipeline that makes it really easy to send binary data, to have it still encoded, broken up, reconfigured on the cloud side, and then make it so that you can then pass it out to an S3 bucket or a different resource, so that you can enter it into, we have like a Hugging Face integration, we have I'm not going to get these all right. We have an OpenAI, like basically all of the different models used that are out there. And so that's like more of a device to cloud AI capability. But then say we have an example, a case study about this when we launched it, where you want to take that photo, the set of photos that you've collect it in an S3 bucket, do a bunch of training, you retrain a model, and then you would push that down to your device for edge processing. That's also possible using cohorts, because basically a model is just a set of numbers.
Software, right?
It's just numbers, right? Like it's really wacky when you really look at like what it is. It's like oh, it's just like
it's binary
math.
It's
matrices. You know, like it's like okay, I don't get any of it, but as a hardware person, I'm like I guess the LED's blinking, so I'm cool. And so basically through cohorts and our releases, it's possible to bundle that together, where now you can push that one model update down to the device without needing to reboot. Often with embedded devices, you need to reboot. You can just push that down and get this new update and restart your model processing. So we had an example of Phlox, which is a company doing this with NR2160s with OpenMV cameras. So they were doing some edge processing there. And they were taking images, doing some processing on the edge, sending the stuff up to the cloud, redoing their model, sending back down to the device, and then reloading that onto the OpenMV. And that like round trip, especially for an embedded thing, right? I mean, like if you're doing this on like a Jetson, like okay, yeah, cool. Like it's a little bit more put together. With embedded, it's a lot of piecing together. So we're trying to make it more cohesive, especially when you want at the end of the day it to be custom hardware. That's the hard thing.
That's true. Making things that are complicated simpler.
It's never going to be simple, but it'll be easier.
Well, it's simpler for the user, right? If they have to do everything themselves.
Oh, sure, yeah, that part.
Right?
Yeah.
So,
if you're starting from scratch,
the,
you're like...
the concepts are complicated, but like another example with Goliath that I really like is the fact that you took a stance on what kind of protocol had to be underneath, and the user never sees it.
That's right, yeah.
They don't have to do any
It just
like...
talks to the cloud, it show you all the retries. If there's retries, it's all UDP based and CoAP, which we think is the most efficient.
And today we still have the debate, like, should it be MQTT or like, and we don't care. It shouldn't be a question. It shouldn't be a question.
It could be. I mean, like that's the thing. Like, it could be a question. There might be reasons to do that. Sometimes it's hard to punch UDP holes through corporate networks if you're doing Wi-Fi, for instance. But a key piece of Goliath IP as well is that edge piece, the cloud gateway piece that you said Dan was on the show. I missed Dan being on the show. I gotta go watch this. How did I miss this? So basically making it so that it is possible to have multi-protocol. We have HTTP and we have CoAP right now. You know, other ones, if they make sense, we'll probably do it. So.
Well, we'll see. We'll see which one. Where's the best? Awesome, Chris. Well, that was nice. I think we're getting towards like the time where people.
I think the official program's starting. The less official. I mean,
the one that
official,
I can contribute and participate to. Awesome. Cool.
Okay. Thanks so much.
Thanks for coming, Chris. Everyone, thanks for watching. See you.
Bye-bye.
All right. Microphone.
Oh, I won't leave it this. Don't worry about that.
Awesome, man. Thank you. I'll see you out there.
Okay. Thanks so much, man.
Okay, and we will wrap it up. Once again, thanks for tuning. See you soon.